Hello everyone! Can you believe that about 500,000 deaths caused by contaminated drinking water each year around the world? Oh my god, that's a lot! The cost of freshwater pollution just in the United States is over $4.3 billion per year. And we all know that rivers are one of the main resources for freshwater. Therefore, we should care about contaminated rivers, as you can see in the left side of the figure number 1. But the question is how? By using computer models to understand solute transport processes, in which we should consider the mass exchange between the main river flow and groundwater flow through a porous media known as hyporheic zone, which is beneath the riverbed, as you can see in the figure number 2. Now you might ask this question that, do we have any mathematical models by which we can predict solute transport processes in river corridors? Good question. The answer is yes. So what's the problem? The problem is that unfortunately all the mathematical models that we have are not compatible with tracer test data. Yes, all of them. And that's really the bad news. But why? Because they all assume instantaneous mixing for the solute that comes to the main river flow. Let me give you an example. Have you ever thought what happens when you put some sugar into your coffee? Does it mix immediately? Let's think about it. I don't think so. It takes some aging time for those sugars to be mixed completely. And I think that the same happens for the solute that comes to the main river flow. Therefore, in our modeling, we should consider the residence time of solutes, not just in the main river flow, but also in the hyporheic zone area, as you can see in the figure number 3, that shows those residence times with 2 clocks, one in the main river flow and another in the hyporheic zone area. It is worth mentioning that the concept of aging has been already used in other fields also, like population dynamics. As my dissertation, I'm investigating such a model. What would be the benefits of that? If I could find that model, we would be able to manage contaminated rivers more precisely than before, and in a way that it is compatible with tracer test data. Therefore, we would have a healthier environment, as you can see in the right side of the figure number 1. Thank you very much.